Hello everyone, welcome to session 4 on isometric projection, that is basics of isometric projection. Session 4 will start. Here there's a basic problem. Isometric projection of a frustum of a cone with top diameter 25, bottom diameter 50 and height 60 mm when it is resting on its larger circular surface on HP. You see here, this is frustum of a cone means cone with apex portion removed. When apex portion is removed, the top surface is also circle, bottom surface also will be a circle, and you have a height of 60 mm. Okay. Now you see here, what you do is, top surface is 25, bottom surface is 50, and height is 60. What you do first is, you draw a line at 50 actual, and draw this line parallel to this line parallel to the 50 square. This is called isometric square. 50 isometric square you draw. Okay. And since height is isometric, take to C 60. Okay. Actual 60 only. Then draw this line, draw the diagonals. Draw from this to the midpoint of this, from this to the midpoint of this, from this to the midpoint of this line, from this to the midpoint of this line. In that way, get 4 centers, center 1, center 2, center 3, center 4. In that way, using this center, draw a circle, draw an arc of a circle. From this center, draw an arc of a circle. From this center, continue this arc. From this center, continue this arc. In that way, using 4 center method, you get an ellipse. That means all circles will be seen as ellipse in isometric. Okay. In that way, you have got this. Now, what you do is, see here, since the top circle is 25, what you do is, the same thing, copy, move and copy and paste here. And then, please understand, for the first time I am telling you some of the things what you can simplify while doing projection of, that is isometric projection. See here, what you do, take this, select this, that is using move command, move, copy and paste here. Then using scale command, what you have here, using scale command, you select this and take a scale of 0.5. Scale factor is 0.5. So that when you take a scale factor of 0.5, 50 will become 25. Okay, it becomes easy. Now you see here, the base circle is 50, top circle is 25, it is ready. Now you move, don't copy, just move with respect to this C and fix it at the end of this line. Okay, fix it at the end of this line and remove this 25 and all that. Okay, then draw these two lines tangents to this ellipse. Tangents to this ellipse. Now once you do this, and hope you know this bottom portion of the curve, no? This portion has to be light. That is why using split command, you split here and select this line and make it 0.13. Okay, and the top surface anyway has to be seen as per isometric procedure. Okay, top surface anyway is seen, and since the entire thing is curvature, okay, left surface and right surface are not defined here. That is why darken only the top surface here. This portion of the thing you make it lighter. In that way, you have drawn isometric view of frustum of a cone. Isometric view, please understand, this is isometric view of frustum of a cone with bottom circle 50, top circle 25 and height 60. Okay, now if you take the entire thing, okay, take the entire thing, okay, using the scale command, and multiply by 0.816, okay, it will get reduced like this. This will be isometric projection. Now I have introduced both isometric view and isometric projection of drawing this frustum of a cone with top circle 25, bottom circle 50, and please understand, whenever the circle is given, you must immediately enclose that in a square. This is called iso square. Okay, and the circle will appear like an ellipse in isometric. Even here, circle will appear like ellipse in isometric. This is problem number 11. Okay, now problem 2. Draw the isometric projection of a hemisphere of diameter 50 when it is resting on its curved surface on HP. See here, isometric projection of a hemisphere. Okay, you see here. So now you have to be careful because from this you have to know the concepts. Now you see here. This is HP, this is VP. Okay, let us say a square prism is placed here. In order to see the top surface, I lifted this solid over this corner such that this is angle at 30 degree, this is 30 degree, front view inclination. It has lifted up such that the top surface is seen. That is, this solid with respect to HP and VP, it is tilted over this corner so that the top surface is also seen. So that the front view inclination of this is 30 degree, front view inclination of this is 30 degree. In this position, since these are all vertical edges, that is principal edges, are all inclined to VP, all will get reduced by 0.816 times the original length. Okay, that is why in isometric projection, since they are all inclined to VP, okay, since they are all, that is this edge, this edge, this edge, and this edge, and all that, they are all inclined to VP, their lengths will get reduced by 0.816 times the original length. In that way, we reduce it for getting isometric projection. Okay. Now you see here, let us say it is a sphere. This VP HP. Now, when it is a sphere, you can't tilt this over a corner. Whatever is that, if sphere is diameter 50, in the front view, even if you tilt this, you see actual 50 only in the front view. I think you are able to understand. Let us say it is 50 mm diameter sphere. You look from here, you can't, unlike the previous problem, no. Here I have lifted over the corner. I lifted over the corner. The base is lifted here. The base is lifted such that all these are inclined to VP. As a result, this I have lifted over the corner. The base is lifted only to see the top surface. So that three-dimensional faces, 3 dimensions of the solid should be seen. Top surface, left surface, right surface. In that way, all edges will reduce by 0.816 times the original length. Here the lengths will get reduced. But in this case, if you observe, if it is a cylinder, if it is a sphere like this, if it is 50 mm diameter, even if you rotate it or even there is no corner or in such a way, in that way, whatever you do, in the front view, whatever angle you see, it will always be 50 mm circle only in the front view. Can you understand? If it is 100 mm diameter sphere, 100 mm circle only you see. If it is 80 mm sphere, 80 mm diameter sphere, 80 mm only you see in the front view. That is why whenever sphere comes, you have to be careful. Whenever sphere or hemisphere comes, okay, in isometric projection, you have to do the isometric projection only. You can't do isometric view. So far, isometric view would have been enough because complications were not there. Whether it is isometric view or projection, the view used to remain same. That is why if they say isometric view, you don't have to change the scale and all that. If isometric projection, you take the scale. Both isometric view, isometric projection, both are similar. But only thing is size will change. But in these circumstances, compulsorily when that is spheres are involved, compulsorily you have to take care of the one particular aspect. In isometric projection, the diameter of the spheres or hemispheres won't change, will not change. Okay, if it is 50 mm diameter sphere, 50 mm only will be seen in the front view. Okay, it won't change. Now you see here, if it is a hemisphere, let us say, if it is a hemisphere, as you know, this is a part of the sphere. This radius won't change. But the top surface, as you see here, will look like an ellipse. No, that becomes isometric. This will change. That means this is a circle. Circle, we enclose it in iso square. As a result, this will be isometric, but this will be true. This you please understand carefully. I'm telling you, when hemisphere has been asked, when you have been asked to write the hemisphere, take care. This is the hemisphere. This top circle will look like an ellipse in isometric, and all ellipse will be enclosed in iso square. If it is 60, we'll enclose it in 60 square, iso square, and finally we'll convert into multiply by 0.816. Okay, this is the circle. If it is 50 diameter, 50 as that is square we draw, and finally convert into iso. But you should know very well, this won't change. If it is 50 diameter, this will be 25 radius. 25 radius should be the actual one itself. You can't change because the diameter or that is the profile of this cannot change. But only thing is, when the hemisphere is there, this will be changed to iso. Okay. Now you see here. Now let us say I want to draw the hemisphere of diameter 50. Okay. Hemisphere of diameter 50. Okay. Carefully follow. Okay. Now what you do? Draw 30, 30, 50 iso square you draw. 50 iso square you draw as usual. And then draw the diagonals. Draw it to the midpoint, 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 and get 4 centers. Okay, first center 1, center 2, center 3, center 4. From center 1, draw an ellipse here. Center 2, draw an ellipse here. From center 3, continue this ellipse. From center 4, continue this ellipse using R command. R command using center and radius. In that way, you do the hemisphere top surface. Okay. Now, immediately convert into iso. That is, select the entire thing and multiply by 0.816 so that iso 50 square is completed. That is, this is 50 iso now, this is 50 iso. Okay, in that way, iso 50, because these are all isometric edges, because the circle will look like an ellipse. These are all isometric edges, this and this, like base of the square prism. Okay, base of the square prism, as you know, it is all edges of the base of the square prism. The principal solid is all isometric edges, hence these things should be reduced. 50 iso, you drew, that is, select the entire thing and multiply by 0.816 so that it becomes 50 iso. Now with CS center, okay, you see here, with CS center, true 25, because the outer profile cannot change. But you know it is a 50 mm diameter hemisphere. 50 mm diameter hemisphere. In that way, radius will be 25. Actually, true 25, you draw one circle here, or the best way is with CS center, tangential to this ellipse's radius, draw an arc. This completes the ellipse. Did you follow? That means you should know very well, R should be true 25, actual 25. But the best way is CS center, tangential to ellipse's radius, you draw an arc so that ellipse is obtained. Okay, so that hemisphere is obtained. This is the way of drawing hemisphere of diameter 50. See here, this should be 50 iso square, and CS center, true 25, you can't change the profile will remain same. CS center, true 25, you draw this so that the hemisphere is obtained. Okay, now we'll stop at this session 4 on basics of isometric projection. We'll continue in session 5 on basics of isometric projection. Okay, thank you very much for watching.